Hello, today we have discussed the uniform convergence most important property. What is the most important property of uniform convergence of functions is that it preserves continuity, right? That means that if we have a function which is uniform convergent, then it preserves continuity. Okay, now let us define the theorem. If a sequence fn of continuous functions, if a sequence of functions which is continuous, right? Functions are continuous, then it converges uniformly on a subset A of R, right? Where the function is defined. Then it converges, if it is uniformly convergent, then it converts to a limit. The limit is f, which is from A to R. So this limit is also continuous. That preservance means that if the function is uniformly convergent, what is the functions are continuous, then the limit is also continuous. There is no difference is that if the function is continuous, then the limit is not continuous. If the function is continuous, then limit is also continuous. That means to say that the uniform convergence is preserve continuity. How it is defined? That it is defined that if we have a subset A which is this subset of R, then C is in A. So when we take fx minus fc, difference between fx minus fc, which is defined as, which we can define as fx minus fnx plus mod of fnx minus fnc plus mod of fnc minus f of c, right? So what is this tell this? Because we have functions of continuous functions, then if we have functions of continuous functions, then we can take, then what we can take that fn is a continuous only, then mod of fnx minus fnc, which is less than to epsilon if mod of x minus c is less than to delta, right? And we have other properties that uniform convergence mod of fnx minus fx, which is less than to epsilon by 3. So we can write it up in the mod of fx minus fc, that is this one and this one. So this will implies that it is plus 2 epsilon by 3, right? It is plus 2 epsilon by 3 mod of fnx minus fnc, which is epsilon by 3. So this will become 3 epsilon by 3, which is epsilon. So mod of fx minus fc is less than 2 epsilon. This proves that the function's limit is continuous.